If you could just
sit over here. The one seat in the house that I can't sit in, I had to sit in. Right?
Thank you. Right there's good. Thank you, guys.
Did this thing die?
Anything want to whiten it?
White, yeah, we're screwed on that. But it'll only affect you and the other person. Or is it, and the other person is
what's
him.
funny is right at the very end, one other person.
Oh, really?
There was 3 people.
Oh, nice.
That's not new though, but it's a good way to know how to do it. You know?
So it's trying to say that here's a man that needs an information. What I'm going to do with it, ladies and gentlemen, we've got John Arrasjid, excuse me. He is VCDX001. He works for EMC at the Office of the CTO. Currently, his focus is on converged infrastructure and workload analytics. So without further ado, John Arrasjid.
Welcome everyone. Thanks for coming. You're having a great day, and I think we're going to have a great time for the rest of the day as well. I'm not going to be here talking about any specific EMC technologies or anything like that. What I want to do is focus on infrastructure design and some things around that particular space. So I won't read everything that's on here, but I will say I bought a couple copies of the new book on infrastructure design that Mark Gabrielski and I worked on with Chris McCain. For those who might be interested, come see us later on, or see me afterwards, or Mark afterwards. But I wanted to focus on one thing. My goal in life is to see more of you achieve what you're looking for in your career, especially if you're looking at doing infrastructure design. Infrastructure design has been going through a lot of evolution, but there's also a lot of things that were old that are new again. So take, for example, converged infrastructure. I'll give you some examples of how I consider that something that's being reinvented from the way we used to do things many years ago. So this is what I got covered for today. Infrastructure design, some tools that you can think about, workloads that I do want to spend some time on so that you can start thinking more carefully about not just traditional client-server workloads, but also what's called from IDC, Platform 3, or I think there's a couple other terms that Gartner and other analysts use. One of the things that we've done in the past, in many cases, would look at a collection of workloads and what types of resources they consume before we virtualize, or before we actually create a solution to actually run those workloads on. I'm going to present you some ideas in that space that may give you some extra opportunities for looking at workloads and understanding how you might design your solutions around them. I have just a couple of quick things on recommendations for documentation for design. And I want to talk about convergence and some of the new things that have been coming out and some things to think about from infrastructure design, the way we've done things, to the way we might want to consider that, not just for cloud, but also for converged infrastructure. One of the things that I do like to say when I talk to people and I speak about the VTUG program or about infrastructure design is, when we look at designing for an individual product, like for example, a mail server or a database or some other multi-tiered app, that's kind of like architecting for building a house. When we start looking at an entire infrastructure, I like to consider that as being designing for an entire city. So house versus city, what are we dealing with? Different contractors, different vendors, different technologies, sometimes the same types of technologies, but we want to have more than just one vendor. We don't want a single source vendor. So we choose multiple different vendors, technology choices. Another thing I wanted to mention was the term architecture design is kind of a combination of two different words and two different definitions. The way myself and a lot of VCDXs look at these terms, design is about creating a solution, and architecture is tied specifically to a component of that design, maybe a particular piece of technology. How do we set up the architecture for networking, for storage, for compute, for security, things like that? Whereas the design is the overall solution. When we take all those different architectures, we merge them together and make sure they're compatible and support each other. Now, this here may be pretty obvious for those who've been doing this for a long time, but when you work on a project, not many people recognize that a project is never actually done for infrastructure design, right? A certain piece is done at that moment in time. We go through and we discover what are the things that a business unit or a customer wants. Based on that, we try to figure out what are the right technical and procedural things that need to go into that design. And that is where we talk about the logical design aspects. We have not picked a vendor. We have not picked a configuration. Then we move into the actual design architecture. We're actually putting everything together, all those different architectural pieces, creating the physical design with a specific set of vendors, technologies, and configurations. And what normally is the last phase is the validation. How do we make sure everything performs and works the way we expect it to, or the customer expects it to? But once we finish that, what happens in 6 months or a year or 3 years later? At some point, you need to come back and re-architect or update or refresh that design. And in some cases, they might be major. Maybe you're going from physical to virtual, or virtual to cloud, or you're going from a traditional server models to converged or hyper-converged infrastructure, or even when you're going from hardware-based networking to software-defined networking. Same thing for other areas like software-defined storage. You have to think about a number of different things that are similar to what you've done in the past. But now there might be some new design guidelines that you need to follow to ensure success. So the way I like to look at this, there's a couple of different white papers around architecture design. The one that I like the most is one that I've used in a lot of my talks, and it basically looks at the model of an owner who has a conceptual model of what they would like to build, and say, build me a house. So then the architect says, okay, well, let me ask you some questions. Let me figure out what we really need. What do you believe that you need? Let me think about the technical pieces and the operational pieces to actually support that. Let's have some further discussions. Let's modify the design. And in some cases, we may find that we may need to modify the customer's expectations and what the conceptual model is. So I had one instance where, this is going back probably 6 or 7 years, the customer had a budget of $100,000 for a particular project, for this one particular area. And they told me they needed 7 nines of availability. So I think you can probably see where I'm going on this. $100,000 will cover certain aspects. But when you look at 7 nines of availability, most customers don't need it. I'm sure there are a number here that may have that need, but there is a cost based on certain expectations. And in that particular customer's case, we found out they actually only needed 3 nines of availability, and we were able to fit within the budget they had for that particular piece of the design. Now, once we actually get through the architect's viewpoint, the architect still needs to build one other piece, and that's the physical design. And this is where we are going to give a set of blueprints and design information, instructions to the builder. I like to refer to this to the plumber. Okay, what do you want me to fix? What do you want me to build? What do you want to put a new bathroom in? Do you want a sink, or whatever it is? That person has to think about how to connect this new piece into what's already existing. Or if they're building a brand new house, what are the different components they're going to include in that? So a lot of times people ask me if I look at conceptual, logical, and physical, what does that look like side by side? And I give you an example here where maybe there's driving requirements around governance, or how we actually use resources or support particular applications. From the architect's perspective, they translate it first into the technical capabilities, and in this case, we're talking about recoverability, applicability, security. On the resource side, compute, networking, storage, there may be other ones as well. But once we get through that phase, and we've got an agreement upon the technical requirements and the technical design that's being recommended, we now can pick the actual physical products. And in some cases, you will find that consultants and architects, and I've done this too, we may actually have a merged approach where we know, for example, when I was working at VMware, we knew that for this customer engagement, we're going to include vSphere as part of the design. So that is a physical component, but we kind of take a hybrid approach. So the design document may have a mix of both logical and physical. In other cases, customers have a strict requirement to separate out the technical and the physical, so the logical design and the physical design areas, because they may want to shop around different vendors, have discussions with other people once they get through those technical requirements. And in these cases, you can see I'm picking specific vendor products and specific versions. And on top of that, there will be specific configurations as well. Now, as we build things out, a lot of this is based on the VCX program, but there are many other certifications out there. Nutanix has a certification for architects. Cisco has one. There are other vendors that do that as well. What we did, going back, this is probably a little more than 10 years ago, we had a lot of architects, both at VMware, where I was working, and from our partner community, to give us input on what they thought were the major buckets that we want to group things in. So you may agree or disagree with these specific ones, but I want to point out that every one of these categories will have subcategories, and that's typically where the arguments might come in. Oh, well, you know what, when we look at recoverability, we need to put backups and recovery separate from some other kind of failover mechanism. We don't really think that way. We call this the AMPRS, availability, management, performance, recoverability, security, but there's also one other area that we always have to factor in, and that's risk. And as we put together a design, I've pulled out some of the key things in here that will actually help you drive and develop a full design. There's a design consideration, so customer gives me a idea of what they want to do to ensure that their systems are running, that they have recoverability and so on. And I need to make certain decisions. Once I make that decision, I need to actually have a pattern that will match that. We sometimes call these best practices or design guidelines for specific technologies. We put that together, and then as part of the design, and this is what I do on a regular basis, I include not just the justification, but the impact to the design. Will it affect the schedule? Will it affect the cost? Will it affect compatibility or interoperability? We have to factor that in. And the last area is risk management. How do we make sure that we can fit within the budget for a particular project to cover the risk requirements, the risk management requirements? I live in California, so my designs a lot of times for risk management fall under availability and recoverability related to earthquakes. I don't deal with hurricanes in California. If you're from Florida, you probably don't deal with earthquakes as much, but you definitely deal with hurricanes. So those are things that you have to factor in. What are the likelihood of those things coming into play? The other thing is looking at workloads, looking at the operations around not just the workloads, but the infrastructure that supports that, and the different technologies. And I'm giving you some examples here. There are other ones that we can come up with, but just to give you an example, things that you're familiar with. There are workloads, so virtual machines and the applications that run within there. And workloads aren't just virtual machines running an operating system. They can be unit kernels, they can be system services, microservices, and things like that. The telco industry is doing a huge amount of work in something called network function virtualization. So many of you have probably virtualized routers before. There's a lot of other things that are being virtualized. And there are strict requirements on availability, connectivity, performance, and things like that they're now working with as they use different software-defined networking technologies to meet those solutions. What they don't want to do is say, okay, we have bought $5 million worth of networking infrastructure here, and based on our requirements, we need 2 or more copies of those $5 million of gear as hot standbys or cold standbys, but they have to be available. So that means they've now sunk anywhere from $10 to $15 million into something to support their governance. With software-defined networking and network function virtualization, they have the ability to do potentially with less duplicate hardware. They can actually look at disparate hardware. They can have a mix of maybe Cisco, Brocade, other types of vendor technologies, and then that way they don't get locked into a single source vendor. The one slide I have on documentation is a question that always comes up. What should I include? Now, in many cases, this is for the VCBX defenses. People ask, how should I set up my documents and things like that. This also goes to customers who are trying to build their own designs. I look at the architecture design piece as having both a functional design and a technical design. The functional design includes the conceptual and the logical design areas. And then the technical design is where we get into the actual physical details, the choices of particular hardware or software set of vendors. And then the other documents, and these are typically separate, but they can be combined, are installation guides, an implementation plan, which might include schedules as well as training, a validation plan. How do we make sure that this will do what was expected by the customer, expected by the architect, and is expected by the users of the applications within the environment? These can include performance and functional testing and so on. And then there are, of course, operational procedures. How do we make sure that day-to-day operations or the other recurring or off-the-cuff type of operations need to be handled? Things like emergency situations. How do we handle a recovery of a particular system if it fails? How many people here deal with workload analysis? Show of hands. Okay, so I see a few people out there. One thing that I would recommend is that even if that's not an area that you are asked to work on or focus on, you need to start thinking about the future, which is actually here today. As we start evolving different pieces of software, new vendors will have new software out, and there are new ways of putting these applications together. Microservices, things like containers. Containers are growing really fast in a lot of different industries. Even if you have traditional client-server models, and it doesn't look like you're going to move directly into that space, at some point, you're going to see more of that happening in your environment as well. Some of the things that I look at are what is the demand profile that drives the resource requirements of an application. So as an example, I may have a 10,000 user Microsoft Exchange environment. Based on that environment, I've got a number of different pieces that are being used, and I know that there's a certain amount of data that is being transferred during a particular time period. So we need to understand the consumption, how those workloads are used over a particular life cycle during the day. You know, Monday morning for email might be very heavy, but maybe Sunday morning might not be, at least here in the US, where we have the weekend on Saturdays and Sundays. There's another area that you may not be as familiar with, and that is something called application types. I'm not talking about a mail server versus a database server. I'm talking about specifically functional patterns that make up an application. Things like storing to I/O, reading and writing, things like doing particular compute areas. And what we try to do in my group is looking at how do we look at these different application types, so that if we have historical data on one application that has a set of application types, how can we use that to predict the use of resources by a brand new application? And that's something that I think you're going to see becoming more and more important as we try to look at the right fit for a set of applications, but allow for growth and allow for changes in that demand profile. There's also the resource consumption area. How many people here have either used the tool to collect data on, or had a consultant maybe come in and work on collecting data on workloads? Things like Capacity Planner, Extreme, Advisor. I'm seeing a few people out there. There are a number of different tools out there. I don't actually pick any one over the other, but there is one that I found that is interesting. I'd like to talk to you if you have further ideas around this. But in most cases, those tools will say, let's do an inventory of all the applications on the system. It now has a list of all those apps. And then it says, okay, let's see how the resources are being consumed. Maybe every 5 minutes or every 10 minutes over the course of some period of time. The one problem I see with that is you've got a set of applications working together on a platform that consume those resources. But now if I want to say, oh, I'm going to have a different mix of those applications, I don't actually have the data on the individual application. So there are some things that are happening with some of the tools that I mentioned. There's also VMware's Hyperion tool that focuses more on the applications and the resource consumption. I think that's going to be an area that's going to be very important for all vendors to start thinking about. How do you benchmark not just one application or a collection of applications? It's more of how do we do benchmarking so that we can combine different types of applications and see how they play out. So DRS has done, VMware's DRS has done this for a while, but it's doing it at one level that I think can be taken a little bit further. So when we architect, in my group, in Octo at EMC, we look at how are things changing and how can we do things better, how can we do things faster. And I think one of those areas is having a better understanding of workloads, rather than just using spreadsheets of data or having one-off discussions on things. We need to standardize how we look at that data. We need to normalize the numbers. So if I compare an Intel i3 and an Intel i7, I'm going to have slightly different types of performance, not just because of the CPU and the speed and the technology there, but also because of cache, because of other things that are supporting that processing as well. And so that's where I want to look at how do we look at an application and the resources that are consumed, and how to normalize so I can do an apples-to-apples comparison with other benchmarking that I'm doing. There's deployment models. Are you going to deploy on a physical platform, a virtual platform, a cloud platform? There's also consideration of, will I do this as one or more applications on an operating system, or will I use a unikernel, which is a stripped-down version of an operating system? Will I also consider using microservices or containers as part of that deployment model? And the last area that I have listed is also one of the most important. A snapshot in time is exactly that. It's a snapshot in time. We can't always predict long-term because things change over time, but it's very important to look at historical numbers to make sure that we have a best fit when we actually do our design. Now, there's one thing I'm going to bring up here. Has anyone here heard of the micro VM concept? Oh, I see a couple of hands. So I'm going to show you a slide on this. The reason why I'm bringing this up is that there are other ways that you can do this, but right now, when I look at workloads, what do I get? I look at CPU, memory, disk, network, graphics, maybe floating point or FPGA type of things that might be important. FPGA probably more on the physical hardware design. But wouldn't it be great if we could have one number or one metric, single metric, that can represent all those different resources? So instead of looking at 7 or 8 columns with a number of different data points and I have to cross-correlate, that can all be done with one. But I do know there are some others. I can look for those later on when we take a break. I can kind of cover some of those. Let me go back one here. I wanted to cover also application type functional patterns a little bit further. This is where we look at what are all the different functions within an application. So it allows us to have workload discussions without calling out specific products. So instead of saying Microsoft Exchange Server or SendMail or Lotus Notes or some other system that covers that kind of messaging, I can talk about these functional patterns. And some of these are listed here. There's a company called Additivity that came up with this one particular set of contexts that I've actually listed here. The examples are business intelligence, administrative workflow, content collaboration, and those are further defined into how those types will consume resources. Are they more on I/O, more on compute, and so on? That actually helps us get a best fit and actually helps us talk about new applications where we have real historical data on how they consume resources. Jump back over. The other thing too is looking at deployment models. So I kind of have a little formula up at the top that says, okay, we use this function called knowledge, and based on that knowledge, there's some application types that I have to look at, to understand how things are going to be working. the resource consumption, the historical details on that, but that will then drive deployment models. So sometimes I get asked the question, should I use converged infrastructure or should I use cloud? It depends. It depends on a number of different factors, including the types of workloads, how the resources are consumed. When we look at Hadoop, for example, that's a really good fit into a cloud model. It may not fit maybe a particular set of servers you have in your environment, but we can actually have it fit maybe within a cloud environment or maybe a converged infrastructure environment based on all those requirements and how we actually drive the design there. The other thing too to look at is how do those applications scale? So are they scaling up? Are they scaling out? Are they kind of doing a little bit of both as far as how you actually do your deployment? When we look at, I have a friend that's co-chair with me on that conference that's coming up in December called Lisa. I'll talk about that a little later. But at SpaceX, what he explained to me is they kind of have to do a little bit of both scale up and scale out. For the most part, they're going to scale out maybe with certain microservices, but they also have a need to do scale up as well to provide specific guarantees without having to do additional deployment outside of that. Now, I'm sure everyone's heard about converged and hyperconverged. These are the definitions that I use and a lot of my colleagues use at EMC and VMware. Look at a platform as an underlying computer system or set of computer systems. We look at converged infrastructure as being hardware focused, where we have each component having a specific purpose in life in supporting these applications. And then we look at hyperconverged as extending it even further, and in many cases, it's a single vendor. And this is where we take more of a software-centric approach. And the idea being is we use a lot more software-defined networking and software-defined storage. Jacob Farber, who's here from Cambridge Computer, was talking with me earlier this morning. He said one way to look at it is, do you want to buy all this different hardware and rely on other vendors to manage that? That's fine. But in some cases, people are choosing software-defined networking and software-defined storage. And so although it's software-based, you're kind of becoming a hardware engineer, but you're working with the software-defined technologies in that space. But I look at this as individual platforms where we run the workloads, and the key difference between converged infrastructure and hyperconverged is single vendor versus a combination of vendors and software-defined versus non-software-defined. I think you're going to find these two converged infrastructure definitions will start merging over time. I'm already seeing that with things that are happening. But we'll see what happens. Things evolve. Some drivers for converged infrastructure. There are things related to the business drivers, business scenarios, expectations. There's the end user experience. There's performance, but there's also other things to think about, usability and accessibility. There are the applications, the types of applications, and how they consume resources and the specific resources they require. In many cases, you're seeing converged infrastructure and hyperconverged infrastructure solutions today that do not include graphics processors or virtualized graphics processors. But those are things that are coming in support of virtual desktop and things like that. And then, of course, there's the different technologies that are in support of a converged infrastructure solution. When we look at the business, this is an area that I've been working with Activity and Virtual Stream and a number of different partners on looking at how do we define the drivers. And within the business, we look at industry verticals. There are going to be some common apps across all industries, mail servers and things like that. But then there might be specific industry technologies, applications, and things like that. Basically, based on the industry, we will have business scenarios. Those scenarios will drive the functional patterns that are needed, the different types of applications that are built on those functional patterns. And that ultimately leads to the choice of an actual application. And so we look at all these things on the right: time to market, agility, scale, cost, and simplification for the user. In some cases, there's a cost to the administrator or the architect on the complexity, but the goal is to make it simpler for the user so they can do their job and meet the business requirements. And it's kind of interesting. I mean, I've seen this as, I've had over 12 years at VMware and 2 years at EMC, and looking at how things evolve over time. Every company goes through new features, And one other important thing as part of developing those new features is the usability for the administrator. But the core focus in many of these technology spaces is the end user. How do we give the end user the best experience for supporting their business functions? And on the end user experience, if you look at how things were done in the old way, a corporation who writes an application or a corporation who wants to use applications, they make the technology choices. In the new approach, and I had this when I was at VMware, basically all the engineers and all the consultants say, we want Macs, or we want to run, a particular OS versus another OS. So there's a lot of areas where the users of the environment, of the applications, are actually helping drive some of the changes in the technology choices that are being used. We want to make sure there's consistency in the user experience. There's, of course, this just-in-time delivery. How many times, if you're an administrator, have you had a user call up and say, hey, I need X yesterday because I have this thing that's due today? I mean, these things come up. And in a previous life, I worked at a company called Arrasjid, and we actually had a requirement to keep, for certain servers, 2 copies. So this is kind of going back to the telco one. So I actually had a budget of what I needed, and then I had to add a certain percentage to make sure I had this other hardware sitting cold on the shelf. And with virtualization, a lot of that has changed. But one of the things that we do get a lot these days are the new development models, agile development, that are driving this just-in-time delivery and support of that. The other area that I'm going to talk about is management and access. So when we look at building out a solution, converged infrastructure can be this pillar. I mean, it may not be for all solutions and in every environment, but it actually has, with the way that we're looking at integrating the different technologies and how we're actually supporting the management, not just of the infrastructure, but the applications within that environment. That actually is one of the things that I see changing dramatically. You're seeing a lot better improvement, I hope, in many of the different vendors. It may not be everyone, but I think that's one goal that a lot of the vendors have. And the other one is cutting that chain of any device, anywhere. So it doesn't matter whether you have an iPhone or a Galaxy or some other type of PDA, or whether you have a MacBook, a Lenovo, a Dell, an IBM, an HP. We want to have the ability going forward to allow any device anywhere, and it actually makes it a lot easier for many companies to do that in one respect, and that is it actually helps satisfy the needs of a lot of the employees and the users of that environment. Find the best tool that works for you based on the work that you're doing. One thing I'm going to show you fairly quickly here, just for the sake of time, is these 3 different platforms. This is not something, some people say, oh, EMC invented this, or somebody else invented it. IDC came up with Platform 1, Platform 2, and Platform 3. The idea of Platform 1 is you may have millions of users on these mainframes with thousands of apps. The second stage is, for Platform 2, is hundreds of millions of users and tens of thousands of apps. And in this particular case, we get into that client-server model, where the network becomes a big part of supporting it. In the third platform, you've probably heard the term web scale or cloud-based apps, containers, things like that. This is where we're looking at billions of users and millions of apps, maybe even more than millions of apps, because now we're talking about Internet of Things, right? How many people here have a Nest or some other type of internet-connected thermostat? I have a Nest. I actually have their fire detector as well. I'm not promoting that. I'm not a sponsor, but I think it's as an example. Now, for those who have those devices, do you have a consideration for security? I do, because as I think about it more and more, okay, does this device have a microphone? It's monitoring when I'm home and when I'm not. For a nefarious person, they might have some objectives of figuring out when I'm not home, based on movement and stuff like that. These are things that are other things that we have to factor in, not just as an administrator, I'm supporting it and protecting certain data, but also for the user to understand and how that fits in. Another question I get a lot is looking at platforms and applications between Platform 2 and Platform 3. I've got an example here of showing what the platform definitions are. So client-server and versus cloud-native. We look at workloads, vendor-driven versus the end user or consumer-driven. And then we look at the different types of elements that make up the workload. So there are application modules typically. We might have, for example, SAP. There might be an ERP aspect or other types of aspects, and we pick one or more of those to work together. In Platform 3, I'm seeing a lot of microservices, for Internet of Things, but I'm also seeing other things that are cloud-based. It may not just be microservices, I'm using this more for a comparison here, but it may include things like unit kernels and containers. So I give a couple of examples here. And if you actually, the reason why I wanted to show the comparison this way is that although Platform 2 and Platform 3 have differences, there are a lot of infrastructure design approaches that will still map the same way. But there are some areas that will evolve based on the particular type of app and how they actually use the resource. Another thing I wanted to point out is, how did we get to converged infrastructure at this stage? We had something like this years ago, and that was a traditional server with storage, and networking, and memory, and compute all in one box. We're going back to it again. Is that good? Is that bad? I think it's actually a good thing because things have evolved over time. I didn't put any dates on here because I may be slightly off on some of the order, but I wanted to show you some of the things that led up to converged infrastructure. Key things that have led to that include new storage technologies like SSD, maybe not so new these days, 10 gig and higher network bandwidth, and then the compute engines that we have and the memory sizes that we have. It used to be that we would never imagine in 5 years the things that happened within those 5 years, and it's continuing to advance. And Moore's law on how we increase, that compute power is still holding valid. I think we're getting close to some of the limits, but then again, we've said that before, and we've managed to beat them through different ways of dealing with things. So this is where we're looking at being driven by technology advances in both hardware and software at the right time and at the right place. Now I'm going to show you a couple of different, for the sake of time, I'm just going to do this very quickly. There's some terms that VCE came up with, and EMC has kind of adapted this across the board. And we have some other speakers here who are actually from EMC that can talk a little bit more about the product. Once again, my focus isn't on the specific product, but some of the technology or discussions around the technology space. Blocks, racks, and appliances. You'll probably see more of this. And I called out here scale out versus scale up. But I want you to be aware, in many cases, something that's classified in one category that should be either scale out or scale up may apply for the other side as well. And so in many cases, certain technologies say, okay, this is targeted, maybe it's a rack system targeted for scale out, but the way that the hardware is architected, it gives you the ability to scale up as well, and actually increase the total amount of capacity within that environment, within that platform. So what does the future hold for CI? Storage. All flash is the primary technology for the storage. I think that's becoming more and more common, especially as price is driven down in that area. But I still see disks, or at least hybrid disks, as continuing to be valid for some foreseeable future. Software-defined is an absolute. It is here. It is continuing to grow. It's becoming more adopted by traditionally hardware-only vendors. Cisco is doing it, Brocade, EMC, in the software-defined storage area. Converged platforms, we're now looking at dynamic converged infrastructure platforms. What does that mean? What if I have a converged infrastructure platform that's targeted to support this particular set of workloads, and I have a need to change that? Wouldn't it be nice just to do a quick reconfigure and say, you know what? Instead of having heavy on CPU and less on storage, I want to do a flip and go from a compute-based converged infrastructure platform to maybe a storage-based one. Many of the vendors are moving in this direction, but I'm seeing much more progress. I think that's coming, that you will see coming, as far as dynamic setup within that particular environment. And this gives you the ability to repurpose older servers by repurposing what applications they're going to support. So something that may no longer work for compute may be perfectly fine for storage, and give it another 5 or 10 years of life. Capacity. How do we get optimized for Platform 2 and Platform 3 workloads? most CI vendors are working to do that. And then there's the composable infrastructure concept that's related to what I mentioned about dynamic platforms I'm going to talk to you about now. So, has everyone here used Lego blocks? You guys all know Lego, right? How many people love Lego? I got the 2 X-Wing fighters Legos because I just love Star Wars too. The beauty of Lego is they have a purpose on how things are built. So here's your instructions. Okay, I'm going to build my X-Wing fighter. But you know what? If I decide I want to build something else and I have the bricks for it, I can go ahead and rebuild it. That's kind of the concept around composable infrastructure. So we look at a disaggregated set of hardware with a fluid pool of resources, meaning we can seamlessly reconfigure to be able to support different workloads. Hardware M&O, software-defined elements, reduced provisioning complexity, self-discovery, and having cloud-enabled solutions. I have just 2 more slides. One is on the evolution of infrastructure design. People, process, and technology, they are already changing. You've heard terms like DevOps. Of course, you've heard converged infrastructure. There is an ongoing evolution right now, yet again, in how things are changing. I lived through the virtualization revolution, at least the last one. This is after mainframes, of course. But we're seeing the same thing happening with converged infrastructure. Now, what I wanted to close with, first off, is I think, I definitely want to say this, and I'm not just trying to run as it, but, VTUG, I think, rocks for several key reasons. One, the community, the attendees, the type of sessions that you have here, the vendors that are sponsoring this. For me, I've been trying to do this for a number of years, and I've always had conflict, so I'm so happy that I got a chance to come out this time. The one thing I want to ask is, are you involved in other communities? And what are those communities? And I'm going to do a little bit of a plug because I just completed my 3rd term as the Vice President for the Unix Association that does things very similar to how VTUG takes an approach. It's a vendor-agnostic nonprofit, and what they do is they put on a conference that I'm going to talk about in just a second. But basically, the synergy is how do we enable people by understanding technology, the process, things that were invented at Unix conferences are things that you know about today. DevOps, site reliability engineering, certain types of hardware technologies. People who've been part of this include Linus Torvald, Bill Joy, a lot of current leaders in the industry for Puppet, Chef. I actually have regular meetings with Eric Allman, who actually is one of the inventors of SendMail. So you actually have the opportunity to meet a lot of both current people who are inventing new technologies and ways of doing things, as well as people who have been around for a very long time. I've hung out with Rob Pike, who works on Plan 9, formerly with AT&T, Bill Cheswick, and there's a lot of other ones that I can mention later on. It's an international community. There are people flying in from all over the world, and they come back every single year. This year, the LISA conference, which stands for Large Installation System In, is December 4th to 9th. It's down in Boston, so it's not too far away. Once again, as I said, there's a lot of synergy. There is a gentleman who's here from Cambridge Storage that I mentioned earlier, who runs this thing called Storage Day. And it's everything you need to know about storage, but you don't have to pay, you have to get there, but you don't have to pay for the conference. And what he's done today, he's going to give 3 repeat sessions on storage concepts that are taken as abstracts from that conference that he's presented on and given tutorials on that I think you'll find valuable. So I would definitely recommend that you stick up with him and get a chance to see what he's presenting. I'll leave this with a question that I have from a number of people about some of the books that I worked on, and Mark Gabrielski, who's also an active member here. We brought some copies of the books. If you're interested in seeing us, we're going to have it at a big discount at the bookstore. And what I'll do is I'll post a Twitter post because Lulu, who's doing the book, is currently doing a 30% discount. And if you're here and you see us, and we still have copies, it's 50% off of the list. So shameless marketing, but you said it was okay. So anyways, the goal of the book is not to get rich, it's to actually help people understand how to do infrastructure design. And we've included both desktop virtualization designs, full designs, and server virtualization designs. And with that, I want to say thank you to the VTUG team for having me here. My apologies for going over just a little bit, but thank you guys very much for having me, and I'll be around to talk to you later.